Welcome everyone. Today we're going to start chapter 9 for CNG 4351, 5351. And in this chapter, we're going to talk mainly about volume studies and characteristics, which is very related to the first couple labs that we discussed and will be discussing in the near future. So what are we going to try to cover in this chapter? Before we get going with that, I would like to remind you with the homework. Homework number 2 is we're having problem 5.2, 5.3, 5.4, 5.6, and 5.10 as homework 2. And the due date is check your Canvas. Everything is in there. So I would just like to again ask you to go to Canvas and check the deadline for the homework number 2. All right, so let's get going here. With chapter 9, we are trying to achieve a couple objectives. The first one is we need to know what are the critical parameters that we need to have in order to complete a full study related to traffic counts. Then we need to define, in order to understand those parameters, we need to define what I mean by the difference between volume, demand, and capacity. And then we're going to talk about the volume characteristics. And then in the second part of this chapter, we're going to cover the intersection volume studies as well as the limited network volume studies. So those are the 5 major points that we need to cover in chapter 9. Let's first define those critical parameters. The very first parameter that we need to be fully aware of is the volume. So the volume is basically, as we defined it a little earlier, is the number of vehicles passing through a point during a specified time period. Typically, if it's a volume, we have to be there for 1 full hour. If I'm staying there for 1 full hour, therefore, the amount of volume, the amount of cars or vehicles going through that intersection, it will be defined as volume, which is number of vehicles per hour. If you do not stay there for 1 full hour, let's say you stay there for 15 minutes, and then you want to have an idea or an estimation how much volume am I expected to have with 1 full hour. This is now what's going to define for us the rate of flow. The rate of flow is basically the rate at which the vehicles pass through the point during a specified time, less than an hour. Less than an hour. For example, again, if I have a certain amount of observation in 15 minutes. So let's say small v was equal to 500 vehicles per 15 minutes. Then the rate of flow will be equal to 500 times 4, and that is 2,000 vehicles per hour. So that 2,000 vehicles per hour, that's not a true volume because you did not stay there for 1 full hour. If you were to stay for 1 full hour, you probably are not going to see exact 2,000. It might be a little bit higher, a little bit lower, like what we discussed in chapter 5. But if you stay there only for 15 minutes and then multiply by 4, that's why, again, we call it rate of flow instead of a volume. Next is the demand. So what's the difference between demand and capacity? So the demand, this is actually the number of vehicles that they have the desire to travel past a point during a specified period. Usually also it's an hour. This demand is most of the time is frequently higher than the actual volume where congestion is existing. So in case you're wondering, what's the difference between volume and demand? Demand is all the people, all the vehicles that wish or have the desire to go through, let's say, this route from point A to point B. Some of them, they decided to go for it and go through the congestion, and that will be towards the volume. But some others may have taken another route to go to their destination, but they still had the desire to go through that. So that's the difference between the demand and the volume. While the capacity is even further different, because the capacity is what's the maximum rate at which the vehicles can traverse a point or a short segment during specified time period. So capacity, this is related not to the demand, not related to the volume. It's actually how much the structure, how much this highway, if it's, let's say, a 2-lane highway, how much these 2 lanes can handle per hour. And that's typically, it's a fixed value regardless of the current demand or even the current measured volume. So those are the differences between volume, rate of flow, demand, and capacity. Let's move one further step here to define them in more detail. So if the vehicles were counted at any point, at any defined location in 1 hour, let's say again, I'm interested, I'm a traffic engineer, I want to count all these vehicles. That's going to go through certain location for certain hour. So the volume from that perspective would be the number of vehicles counted passing the study location in that hour, the actual number. If you stay there for a certain intersection or a stretch in a highway, the volume is basically how many are going to see while you're there for 1 full hour. While the demand is actually, it's the volume plus all the vehicles that wish to pass through that site during the study hour who were prevented from doing so by congestion. That's again, that's the difference. The volume is what's in there. The ones who decided, you know what, Google Maps telling me still there's congestion, but you know what, I'm just going to take this route no matter what. This is the volume, what you see in real life. Demand is the volume, which is coming from here, plus whoever, the motorists who wish to pass through that point, but they decided to go through another route. While the capacity, this is the maximum volume that could be accommodated by the highway at that study location. So the capacity is also somehow related to the volume, which is defined as the maximum volume. Very important here. So this is the maximum volume because capacity is capacity. Every lane can handle that much, and the volume can be lower. Again, if it's off-peak hour, volume will be significantly lower than capacity. But at the worst case scenario, and the peak hour where now the volume is the highest, the volume cannot exceed the capacity anyways, and that's why here we can say that capacity can be higher or equal than volume. Again, it's gonna always be equal in the case of if we're reaching now full congestion where both of them are equal. Let's explain this more now in a true situation that we see on a daily basis on urban cities where they have lots of roadways that they are intersected and with each other, especially in a congested peak hour time. And that's what we have here, what we call the bottleneck location. I don't know if you've heard it before but this is a true problem, true situation that we see it again on a daily basis. So what are we trying to say here is, let's go through this example, which is going to give you more details of what I'm trying to talk about. So here we're having 2 highways. Each highway has 2 lanes per direction, and then at a certain point they're going to join together. And then once they join here, they're going to join into one big highway that has 3 lanes total. So initially, we used to have volume worth of two lanes worth of volume from approach 2, and we have another 2 lanes from approach 1, and now they're going to join into only 3 lanes. This happens again. This is what we call the bottleneck. Why we call it bottleneck? Because as we're going to see, the numbers now are going to be problematic. So let's talk about it in more detail. So let's assume first the capacity is about 2,000 vehicles per hour per lane. This is fixed, as I said. It all depends on the dimensions, how many lanes per direction. So that's again pretty much fixed. So it's 2,000 vehicles per hour per lane. So that the capacity of the 2-lane highway approaches are going to be 4,000 vehicles per hour each. If I tell you that every lane is going to handle 2,000, therefore approach 1, the capacity for approach 1 will be equal to 2,000 times 2, and that is 4,000. And that's actually reflected here. The C, the capacity is for 4,000. Same thing for approach 2. Approach 2 here I have 2 lanes. So the same thing, I'm going to have the capacity of 4,000, which is 2,000 vehicles. Where did we get the 2,000? Again, all the way from here. 2,000 times 2, that is 4,000. So again, this is not a measured number. This is a known number even before you go through and before you go to the field. While, how about the capacity now for this joint highway? The capacity is 6,000. Why 6,000? Because it's 2,000 times 3 lanes. That's why it's 6,000. So that's the capacity. Then, now when you go to the field, you will be able to see and measure the true volume. So, for example, for approach 1, assume that we went there and we saw that the true demand is 3,800 vehicles per hour. 38. So you go there and you measure it, and now it's 3,800 vehicles per hour. So the demand in this case is the same as the volume. They are equal. Why is that? Because the capacity is 4,000. That means everyone wishing to use the highway is there, because we're handling way less than the capacity. If we're not approaching capacity, then the demand will be equal to the volume, like what you see here. So the demand is 3,800 and the observed volume is 3,800. Same thing for approach 2. You go there and you happen to measure that the demand is 3,600 and the volume is 3,600. No problem. As long as the volume and the demand, they are less than the capacity, there is no problem. We're not going to have congestion. But what happens now is, once these two approaches join together in this bottleneck situation, now all of a sudden the capacity is fixed. It's 6,000 vehicles per hour. That's not going to change. But look now what's going to change. The demand is basically the summation of what you see from both approaches, which is 3,800 plus 3,600. 3,800 is coming from approach 1 and 3,600 is coming from approach 2. The summation is 7,400 vehicles per hour wish to go through this highway right here. But the volume, in this case now, the volume is actually going to max out. The volume is going to be the maximum capacity. That's why the volume now at this location is actually equal to the capacity, because we can't handle more than 6,000 anyways. So here you could see the difference, where the volume now is equal to the capacity, but the demand, there is 7,400 people, 7,400 vehicles wish to go through this highway, but only 6,000 will be handled at that moment. And with time, sometime it take an hour or two to release the rest of the volume, and therefore we're going to have this what we call the bottleneck situation. Why? Because we had 2 lanes from approach 1, 2 lanes from approach 2, joining in 3 lanes, and all of a sudden now we do not have that problem, and that's why we tend to see this area right here and this area right here, what we call queuing area. We're going to now see congestion. We're going to see now not everyone wish to join the intersection. They will be able to, simply because the demand is about 1,400 vehicles more than the true capacity. If you sit here for that hour, you're going to measure volume is going to be 6,000. This is the maximum that these 3 lanes is going to handle anyways, but the demand is 7,400 vehicles per hour. How can we fix it? Typically, again, this is hopefully, you would hope that this length here is a short distance, and afterwards you tend to see that the highway will add another 4th lane. And that's why it's, after you get away from this bottleneck by maybe 500 feet or 1,000 feet, or maybe sometimes expand to half a mile, then you're going to start to see 4 lanes again. And once you have 4 lanes and instead of 3 at the bottleneck right here, then there is no problem anymore. That's why we call bottleneck situation or location, because it just exists right here where you have a transition from 2 lanes for approach 1 and 2 lanes for approach 2 into 3 lanes only. And therefore here you see the demand is exceeding the capacity and problem will start. So I hope now again you could understand the differences between the volume versus the demand and versus the capacity. And if the demand is lower than the capacity, therefore the demand is equal to the volume. But once we reach the bottleneck, now the demand can definitely exceed the volume and therefore exceed the capacity for a certain amount of time, especially for peak hours. All right. So I think this is here, again, more explanation. So the downstream of the merge, however, the capacity is 6,000. Yeah, we sum up the 3,800 with 3,674, way higher than the capacity. That's why we're going to exceed the capacity at that segment. So given the scenario, what can we expect to observe again? We're going to have issues and congestion around this area starting from these two approaches for extended amount of time until again we reach a more like four lane intersection or 4-lane segment, and this is how can we fix the problem. Another way of fixing this bottleneck problem, and I have seen it in other states such as Arizona, they actually, instead of having 2 lanes from here and 2 lanes from here, that means again lots of cars trying to reach this point here, they would put actually at this location and this location here a little traffic signal. That traffic signal is just green versus red, which means that, for example, for approach 1, let me draw it one more time here. Approach 1, I have 2 vehicles lined up to join the big intersection or the big highway. Now we're going to have here a signal like this. It just has 2 lenses, one for each lane. So this one would turn red and this one would turn green, and then it's going to keep alternating, meaning that in reality I'm now allowing 1 lane to join the major highway instead of 2 lanes at the same time. It typically, again, it try to alleviate some of the problems, of course, in the bottleneck area. It's a good solution. Is it really a permanent solution, or is it really the best solution? We can argue with that, but at least here we're trying to reduce the amount of really the demand coming from the 2 approaches to a lower number, so we don't get to the bottleneck situation to be extended to more than, again, half a mile or so. Again, that's one of the solutions. I would highly recommend you to look up on the internet what can we do for more potential solutions for bottleneck situations. All right. Still continuing talking about volume, demand, and capacity. So the first graph here, this is here. The graph talks about the demand and capacity as they would appear at the measurement point. So what happened is comparison, in real life comparison between demand and capacity would show that the demand shown again would be observable if it were not clear that the capacity consistent is present. So what does that mean really? Typically the capacity is fixed, let's say 6,000, and the demand again will be very low at certain time, and then it's going to increase at the peak hour way more than the capacity, and then it's going to go down again. But in reality, this is not what happened. In reality, this what happened, which is this is the volume pattern distorted by capacity limit. So the volume can never rise, as you could tell, to the level higher than the capacity. Capacity is fixed, as we say, the 6,000. So what happens is this is the theoretical demand. But what happened is, again, the demand will keep rising from any low amount until we reach the maximum. The maximum is the capacity, the 6,000 from this picture right here actually. So what happened, we're gonna see then that we're gonna reach our capacity for extended amount of time. So instead of theoretically it should last for, let's say again, somewhere between 30 to 60 minutes, where the demand is higher than the capacity. In fact, that's not going to be the case. We're going to have now, we're reaching the capacity, and once we reach the capacity, it's going to take us, this is the output, this is really reality versus this is here theory versus this is the actuality. So it's gonna take us about, again, maybe from here all the way till here. So this is, we're talking again somewhere between 1.5 to 2 hours in some locations, and then afterwards the demand will be lower than the capacity and the problem will solve. So Why is this? Because again, not all vehicles arriving can be accommodated, and the peak period of flow is basically will be lengthened. That flow during that hour is going to be lengthened until all the vehicles can be served. And again, that can take up to again couple hours at some locations, depending on how bad the bottleneck situation there. Now let's talk about some more of the volume characteristics within 24-hour variation. So here we're talking about the hourly traffic variation patterns and how can we observe the peak hour, and is it observed or not? Do we observe it during all days or specific days? Do we have one peak hour during the day or two or maybe three? So let's take a look at this here and trying to understand what's going on. So we have three pictures or three graphs. So the first one here is for intercity route, and the second one here is for recreational access route, and the third one is for local route. I would tend to start with the last one, the local route. Like again, typical local route that we have in the city, and this is what we typically tend to see in our city as well, where the typical variation happens, and we typically see three major peaks, especially during weekdays. Like for example, here on Wednesday. On Wednesday, we could see that there is AM peak hour. We can see here the PM peak hour, and we could see here the lunch peak hour. That only again happen during weekdays. During Saturdays or Sundays, as you could see here, again, people are not gonna be waking up at 6:30 to go try to go to work. So what we tend to see again, there's no peak in the morning. There is some peak here, or the volume is increasing during lunchtime, but actually people would tend to go to have a dinner or go outside and have some PM activities, and that again, that's why we tend to see the peak during Saturdays and Sundays only again here, which is again somewhere between to 7 4 to 7 p.m. For recreational access routes, which is the second graph right here, we are seeing also one major peak, regardless if it's a weekday or a weekend. If it's a recreational place, that means it's not going to be highly and heavily visited um, throughout the hours. We're not going to see again three peaks. Basically, what we see here, and especially we could see all the three lines, either a weekday or a weekend. We tend again to see a major peak again at the PM peak hour, somewhere between again 4 to 7 p.m., where people arrive or even leave the recreation place. But there's no AM peak hour, simply because everyone will tend to pick their own time. They're taking their time when to leave their houses, when to arrive at this recreational place. Same thing for intercity. For intercity route, it's a little bit more interesting here, where um, this is between cities. So we see peaks, and that peak here, we can see a little bit of a peak here, and a major peak here during weekdays, because now there's still people are leaving one city to work in another city. So it the AM peak hour might be different. Again, someone may tend to drive 2 hours to reach their workplace, and therefore they're going to leave earlier than the ones who are just going to take 30 minutes to reach to use that intercity route to go to to go to their work. That's why you tend to see not much of a peak in the AM time, but everyone would be using the same route around the same time, which is again about 5 p.m. or so. Same thing during weekends. Again, not much going on in the morning, but you may see also one peak during the PM time, especially again if people are visiting their family members, relatives, and doing social events using this intercity route. It would be highly trafficked again at the somewhere between 5 to 7 p.m. And that's what I'm mentioning here. So only the weekend pattern on local rural route will display the expected AM and peak PM peak hour, like what we see here. While the intercity as well as recreational, they will only have again one peak hour, only one single peak hour, and the rest is more dispersed peaks because again, not everyone will leave or reach their destination at the exact same time. So that's variation among again among 24 hours. How about now if I want to look into hourly variation patterns, and this is now in an urban location. So the previous example here, I want to point out that this is rural route, whether it's a local street or recreational or intercity, but still we're talking about it's a rural environment. If it's now the same traffic variation, I'm interested to see the 24-hour variation, but now in an urban setting, how things are looking like. So here we're taking a look at 4 different sites, and we're interested to see what's the pattern here. I'm gonna put my notes up front so you guys will follow up with me. But what I want to tell you first, that site 1 and site 3, they are at the opposite direction of site 2 and 4. So 1 and 3 are in one direction, and 2 and 4 are in the opposite direction, which are again only 2 blocks apart from the same facility. But again, I want to show you here that, for example, we're seeing a mirror usage of these 4 different sites. Like for example, in site 1 and site 3, I can see mainly there is a PM peak hour, while now people going back to work, they're going to use the opposite direction to go back to their homes at or vice versa. Here looks like it's site 1 and site 3, they are heavily used and people going back to their houses. But in the morning we could see site 2 and site 4 is serving people going from their residential houses to work. So site 2 and site 3, yeah, it's the exact mirror to the performance for site 1 and site 3. Sites 2 and site 4, as you could see here, 2 and 4, they're only showing AM clear peak hour. After that, everything else tend to be uniform. You can easily draw here a horizontal line. That means there is not much going on. There is no specific peak hour after the AM peak hour. For site 1 and 3, it's opposite. We see that there is an evening peak hour, which is right here again, these 2 evening peak hour, while the rest is off peak hour. So here and here again, not much going on. For site 3 in specific, we're also displaying here considerable off-peak hour traffic volume for site 3 compared to site 1. Like site 1, again, really the average is about here, so it's about 200 vehicles per hour away from the peak hour. But for site 3 is actually the average somewhere about 600 vehicles per hour. That's another observation. The last observation we could see here that only site 1 in particular shows a strong PM peak hour. That the site 3 here again, there is again, it's going on a little bit up here, but is not as well defined as site 1. So you could, again, those are the major things that we can see and observe looking at those 4 sites in an urban setting. Again, if I show you similar pictures, you need to tell me as an engineer now, what do you see? I don't have to tell you that site 1 and 3 in one direction and site 2 and 4 in the opposite direction. I can flip the numbers and you should be able to tell me that from looking at the picture, you probably, again, site 1 and site 3 are in the same direction compared to site 2 and site 4. You can easily tell me that site 2 and 4, they are serving more vehicles or more volume in the AM peak hour by looking at these two peaks here, site 1 and site 3, the PM peak hour. You can also say, if I just show you two sites like site 1 and 3, you could tell that site 1 has more defined PM peak hour, but after that the volume is very low, about 200, versus site 3, the PM peak hour is not really, again, well defined, but overall, away from the peak hour, we still have considerably high amount of volume, around 600 vehicles. So those are the things, again, that you would expect, you would be expected to explain given such graphs. All right, another more details here about the volume characteristics related to the hourly traffic variation. So now within the hour, so let's say again, between the two graphs or the subgraphs that I showed you before, one for urban and one for rural, now I'm interested to see the hourly variation within that peak hour. Let's say now I define what's my peak hour, but now what's the variation within that? Before we get going to this, as you could see in the urban setting in particular, like what we saw here, we tend to see in the past 10 years or so that we're not seeing very well defined PM or AM peak hours. It's actually, there is an absence of clear AM and peak hour in many major urban settings, a spreading phenomena. Again, we don't see that anymore. For example, one major facility, which is in Long Island Expressway, which is I-495, and that's in New York. A recent study actually showed that a typical weekday, only there is one peak, and that peak basically extends for at least 10 to 12 hours a day. So really, it's an entire madness from, let's say, 7 a.m. till 7 p.m. or 6 a.m. till 6 p.m. You can't really distinguish that it's just a bad hour. It's basically horrible. And the peak hour is basically 12 hours worth of congestion at some of the major urban areas nowadays. There's direct result of system capacity constraints. What's the result of this phenomena? That everyone who would like to drive during the normal peak hour can't be accommodated. And that's why, again, we're going to link it back to the demand. The demand is way more than the capacity. So not everyone wish to use I-495 is really using it. Again, so many people would tend to use another alternative, or the major alternative that we've seen, that individuals now will begin to make travel choices that allow them to increasingly travel during the off-peak hour. So now not every single job in big cities like this, they would have an 8 to 5 job. Otherwise, it just, again, they're going to take too long. They have to leave their houses like at 6 a.m. to reach their workplace at 8 a.m. Instead, we see a shift now where work will start at 9 a.m. and finish at 6 p.m. or work will start at 10 and finish at 7 p.m. simply to avoid the peak hour time. And that's, again, it's a rising phenomena, but it's happening. And that's why, again, back to these graphs here, this is why we have such phenomena here. Again, there's not much, no peak here, because everyone is picking their own time to leave work or to come to work. Otherwise, we tend to see, again, more defined peak like site 1. All right. Next is here we have the hourly traffic variation patterns. Again, still talking about the peak hour. And when we now go to design phase, the design phase, which we've talked a little bit about it last chapter, is that for rural settings, we typically pick the 30th highest hour of the year, and we base our design based on that 30th hour. So we put all the worst peak hours in that here in a descending order from the highest till the lowest, like for example this one right here, and then we pick the 30th somewhere here and we go all the way up, and we pick that this is the hourly volume worth of AADT, which is average annual daily traffic, and we do our design, traffic design, and how many lanes we need based on that hour, which means that again we're gonna have another 29 hours really bad, and we're not gonna serve everyone, but at least for the rest of the hours of that year, everything's gonna be fine. This number, 30th hour, tend to work fine for recreational access or rural. But when it comes to the urban setting, we tend to see for urban roadways, we tend to pick actually the 100th hour, not the 30th hour, which is somewhere here. How to pick this one? This is actually more or less like the inflection point. If you may ask me, how did we end up picking this? Yeah, for the recreational vehicle for the recreational axis, you need to draw like the slope of the initial point and the slope of the secondary point. And let me draw it one more time here. So I have this line here. So I'm gonna draw the tangent, draw a tangent for the second line, and this is the point of interest. So it happens to be the 30th hour for rural or recreational, but when it comes to the urban, like these lines right here, you could see that this change, drastic change, happens around the 100th hour instead of the 30th hour. The 30th hour is going to be all the way up here, and again, that's not the true number. And if we're doing it, especially in urban, we're going to base all of our design based on the 30th hour. We're going to have very conservative design that we may not be able even to do in an urban setting, because that may trigger like I need like 8 lanes per direction for every urban interstate, and that doesn't happen. So, but yet we tend to see again it's around the 100th hour, and again, even this table right here would tend to show you that what's the percentage of the average annual daily traffic occurring in the first peak hour or the 30th peak hour or the 100th. So for example, main rural road, again, I tend to see 15%, the percent of ADT occurring in the first peak hour is 15%, which is a high number. And then the 30th is 13, and then after that, again, hundreds or 200 is about the same. But for urban setting, again, for the first hour, the percent of ADT occurring in the first hour is 11.5%, not that much. 30th is 10.5, 100 is 10, now 200 is 9.5. And that's why here we tend to pick, again, the 100th hour to be more, again, somewhere in between, not too conservative, but of course, not too risky. That means we're going to end up with a design that handle all the hours except 99 hours of the year. And that's basically what do we mean by the 100th hour versus the 30th hour. Now, let's talk again about the sub-hourly variation within certain times, like within the peak hour. For example, here, this graph shows us a study that showed the volume for every 5 minutes. And instead of every 15 minutes, this is per 5 minutes. So you could see from 7 a.m. all the way to 9 a.m. and every little bar of this bar chart is showing 5-minute worth of flow or volume. And this actually shows us that how accurate we are to estimate the volume based on the worst 15 minutes. And this study actually showed that we may need to look into the worst 5 minutes instead of the worst 15 minutes of the hour. It's pretty more intense, but that's actually, this study shows that, for example, if the peak hourly volume based on the 15-minute is that much, which is 1630 vehicles per hour. If we were to pick, this is here the worst 15 minutes and it's 1630, and then this would be the peak hour volume based on that bad 15 minutes. But if I were to pick the worst 5 minutes, which is right here, so this is actually, if you go and trace it all the way down, this is going to be exactly from 740 to 745. This is here 740 to 745. This number here is about 2200. The estimated the flow rate, if we used that worst 15 minutes, would be 2200 vehicles per hour, while if I use the worst 15 minutes, it's going to be about 1630. So you could see again huge variation. Still actually the practice is to use the worst 15 minutes. If you use the worst 5, again you're going to end up with very conservative design. You're going to need much more resources to build that facility. So, but I just wanted to tell you and share that with you that there is more studies nowadays that shows that we may need to look into the worst 5 minutes and base our flow rate based on that, and instead of looking at the worst 15 minutes. And you could see, I hope you appreciate the difference of estimation between the worst 15 minutes, which is about 1600 vehicles per hour, versus just picking the worst 5 minutes, and that would be 2200 vehicles per hour. Huge variation. Now let's talk about some daily variation patterns. So instead of more talking about variation within 24 hours, now we can see variation during weekdays and weekends. So what do we see here? We see first we see Monday through Sunday, so it's the full week, and then we see different types of roadways from rural routes, like the first one here is main rural route on I-35, which is this one right here. And we also see the recreational access route, which is this one right here. And these two, they look and display very strong peaks on Fridays and Sundays, as you could see. So the first peak is observed on Friday, and then the second peak observed on Sunday. This is actually very normal. This is again rural, main rural road in Minnesota, and it's a major part of the interstate I-35. Not many people will use interstates, which means again it's not going to be a long ride during weekdays, yet people will be willing to use it, and they are willing and they are using it to go to their destination on Friday. And that's why here we have the Friday PM, the Friday peak, and then people will stay wherever their destination are, and then they would leave, and we're going to have even a bigger peak on Sunday where everyone is coming back to their houses to start a new week. That's actually the opposite if we look into the suburban freeway, which is the continuous line right here. The suburban freeway obviously caters to commuters, and for commuters, commuter trips are virtually, again, the mirror image of the recreational trips, with peaks actually occurring during weekdays, and the demand is going to be very low during weekends. So you could see here again, Saturday and Sunday are among the lowest, while again Monday also, again, not everyone may join their work exactly on Monday, but the highest, again, we keep seeing high numbers on Tuesday, Wednesday, Thursday and Friday, and then not much people will be interested in using a suburban commuter roadway during weekends, because people are actually transferring their usage from that facility to another facility, either a recreation facility or a main rural interstate, where people again traveling from one city and staying in another city for 2 days and coming back on Sunday night. So we've moved so far from from hourly variation to daily weekday variation, and now even we have monthly, or what I like to call it, seasonal variation as well. So here we have two pictures here. The first one is routes with significant recreational traffic versus this one here, significant business traffic. So what do we observe here? What we observe is, first of all, for the recreational traffic, we could see that there is mainly a big peak, very high peak, during certain months of the year. We have a high peak here, let's say from July till August. This is summertime, which means this location has good weather. People would like to go there and spend extended amount of time there. So that's why you tend to see that there is a huge peak in average annual daily traffic during these months for recreational traffic. Outside this range, you could see now the amount of ADT is very low. People will be at school, they will be back to work, not much of interest there. And that's why, again, there is a huge variation between the peak time, which is again about 160, again at approaching 160, all the way down to not even against about half during off-peak off the summer, and that's again somewhere between 80 to 90. And that's again the monthly daily variation in that recreational place. When it comes to the business traffic district, we don't see that peak that much because there is always movements going on. We could see again a little bit of a peak, but that peak again is not really a peak because the highest number is about 110 to 120, which is actually very similar to around here. So that's not a peak. Why is that? Because again, we could see that there's always movements. It's not going to attract people at specific months of the year. Do we see a difference between Saturdays, Sundays, and average weekdays? We see that difference a little bit in the business traffic roadway. Again, you see here there's some difference between Saturdays and Sundays and weekday, but we see that difference way more in recreational. So you could see here during weekdays, average weekdays, the peak even within the summertime is barely 125 or 130 vehicles. But for weekends within the high summer season, numbers will for Saturdays and Sundays, these two right here, the peaks again are approaching 160 vehicles. So that would tell us that we could see there is a monthly variation or seasonal variation, depending again if you're going to a recreational route or a business traffic. At the business traffic, you're not going to see that much of a peak anymore versus the recreational route. But even within the recreational route, where we see that there is a significant peak during certain months of the summer, yet the peak will be signified in weekends compared to weekdays, like what we see here. So with that, again, we finished the first part of this chapter, and we'll see you next time for the second part of chapter 9. Thank you. Bye-bye.